Hi guys, Dr. B here. This is topic 1.3 for AP Chemistry, elemental composition of pure substances. The objective for this topic is to be able to explain the quantitative relationship between the elemental composition by mass and the empirical formula of a pure substance. A pure substance is one with constant composition. A pure substance can either be an element or a compound. So you can have the substance being one atom can be made from anything, and it's described as an atom, such as magnesium, zinc, neon. It can have more than one element, so it's ionic if it's metal and nonmetal, you should know about. It is described as formula units. More than one element if it's molecular, so two nonmetals, it's called a molecule. Atom or group of atoms with a charge is described as an ion. When dealing with compounds, you can assume they follow the law of definite proportion, which states that compounds with the same elements in the same proportion are the same compound. So that means that if you have, say, two compounds of CO2, so you have one CO2 and another CO2, it's because you have the same proportion of carbon and oxygen for both. That means it's the same compound. Following the law of definite proportion, you can find the percent composition, which is the percent by mass of each element that makes up a compound. To calculate the percent composition, you divide the mass of each element in a compound by the total molar mass of the substance. In compounds, the empirical formula represents the simplest ratio of one element to another in a compound. The molecular formula represents the actual formula for the substance. So to determine the empirical formula, assume you're given a 100-gram sample, so you can change the percent to grams. For each, I'll just do it. It's easier. It's fine. So a certain sugar has the following composition: 40% carbon, 6.70% hydrogen, and 53.3% oxygen. What is the empirical formula? So I kind of cheated and put the calculations right there. You can kind of see it. But so let's see what do we do here. So we have carbon. So 40%, we'll assume it's 40 grams. Hydrogen, 6.0 grams. Oxygen, 53.3% per grams. You divide by the molar mass because you're converting grams to moles. So in 1 mole of carbon, it is 12.01 grams. You see that gives us about 3.33 moles. Divide 6.70 divided by 1.008, that's the molar mass of hydrogen. You end up with approximately 6.65 moles. Same thing for oxygen. 1 mole of oxygen is 16 grams of oxygen. So you divide the two, you end up with 3.33 moles. That's the first step. Second step, you divide by the smallest number of moles. Divide all these by 3.33. We end up with 1. End up with 1.995 as you see, so it's approximately 2. Then 3.33 divided by 3.33 is 1. So these numbers right here, it gives us the ratio for these elements in the empirical formula. So the empirical formula is going to be CH2O. Sound familiar? Hopefully it does. If the molar mass of this compound is 180 grams per mole, what is the molecular formula of this compound? So you are going to take your empirical formula, and you have to get the mass of it. So CH2O, the mass is going to be, it's 12.01 plus 2 times 1.008 plus 16 is going to be 30.026 grams per mole. So you're going to take the molar mass given in the problem, 180 divided by 30.026. You end up with approximately 6. So you're going to take this 6 and distribute it through the empirical formula, sorry. So it becomes 6 times CH2O is C6H12O6. A compound is found to contain 56.5% carbon, 7.11% hydrogen, and 36.4% phosphorus. Find the empirical formula. You can see that I have the calculations there, so you can see how to do it. So, carbon, 56.5 grams of carbon. Hydrogen is 7.11 grams. Oops. And phosphorus is 36.4 grams. Sorry, my handwriting sucks. Divide by the molar mass. Should be 30.97. So you can see the calculations. We get 4.70 moles for carbon, 7.05 moles for hydrogen, and 1.17, so 1.18 moles divided by the smallest number of moles. So you have 1 phosphorus. 7.05 divided by 1.5 is 6. And then 4.7 divided by 1.18 is going to be 4. So our empirical formula is C4H6P. If the compound has a molar mass of 170.14 grams per mole, what is the molecular formula? So C4H6P has an empirical formula mass of 85.05 grams per mole. So you take your 170.14 divided by 85.05, you'll end up with 2. So you're going to take your 2 and distribute it. So you end up with C8H12P2. All right, that's it for now. If you have any questions, please let me know. Hit the like and subscribe. Thanks, bye.